That's all super interesting. It's like here at Descript we have we're integrating AI into like a chat bar, and it's supposed to like interact with our document model for like a project. And I think one of the big problems we've had is getting like good input and output, and like making it like I don't know, deterministic. How do you like deal with that? Because
Mhm.
like when I'm talking to like non-tech people about I always try to frame AI very specifically that like classic programming, we're used to being able to get to basically zero bugs. Like classic programming, you have an input, you get an output. If you find a bad output, you can change the code, get the right output eventually. AI inherently isn't like this one-to-one mapping. It's like this like one to n mapping. So how do you like deal with that in your code and like shipping applications built on top of AI?
So there's a couple of things that I do. Number one, I write specialist programs that'll do a particular thing really, really well in SudoLang. So programs that write programs. So in those programs, you can give it really good constraints around the style of code to use, and stuff like that. So it's if you do it that way and you do your interfaces right, for example, you can make it always use functional styles and always use very minimal small functions and compose those together to form the application. And then when you do that, when you keep the functions really short, it tends to produce pretty much the same function definitions every time, which is cool. All right. But that's not the only way to be. And maybe thinking about it as deterministic code output is the goal is the wrong approach. The right approach is it deterministically passes all these tests every time. Right. And it won't do that for a single run. So sometimes it's going to go off track. It's going to make mistakes. But if you first have it write a test suite, right, and then run that test suite on the code that it outputs every time, then you can make sure that your requirements are all met. So that's where the T in the AI TDD comes from. And I often leave the T out because in my mind, if the T isn't there, if the testing isn't there, then you're not doing software engineering. I don't know what you're doing, legacy weird. I don't know what you're doing, but it's not engineering, right? Engineering implies that the code that you write, you prove that it works. All right. You prove that it works. You don't just like rely on luck. You don't roll the dice and even if you're not using AI, humans have the same kind of mental processes that AI have. AI is based on human brains and how they work, right? The modern deep learning AI, it's neural networks, and a neural network is just like this thing that registers inputs and does some summing and produces some output signal. Your brain is made a bunch of those. A neural network is just a big multi-layer, lots and lots of arrays of parameters, and each parameter is just a number, and those numbers are just doing matrix multiplication to produce the output. So it's taking a bunch of inputs, summing them, running a little softmax function on producing an output, and that sum from the inputs into that output. That's how your neurons work, essentially, right? I'm glossing over a whole bunch of differences with like the underlying substrate, right? Like it's not wet, it doesn't require blood, right? But other than that, like the basic idea is the same, right? We take a bunch of signals, we sum them together, we produce an output, which means that a lot of the problems that humans have, like lapses in working memory and attention and forgetting things, AI can do the same thing and have the same kinds of mistakes. So in other words, if you use the same kinds of quality processes that you use with humans, code reviews, unit tests, things like that, to ensure that the quality bar is met, then you can get similar results with AI. So just think about your AI like another human collaborator that you have to watch because they might make mistakes.
This is why I've always
Right.
appreciated the sort of language around collaboration with chatbots, and anytime we're using LLMs to sort of write code, it's not like a magic machine that we give it a very bare base English specification and it like comes out with this magical code that always works and is bug free. It really is. It's like getting like I don't know. It's like getting someone who's like really well read in the documentation, but like maybe isn't always paying the closest attention to write the code. And it's like, sometimes it's like on course and it can be off. But yeah, like things like generating tests, I think are an incredible
Yeah.
strategy, and especially because you can really think about like what is the intent of the thing before it's really written. Like especially you're thinking about interfaces and you're thinking about tests before you're thinking about actual implementation, and like you know it leads to like a good model.
Yeah, exactly. That's one of the things that I love about SudoLang is like I'm only thinking about the interfaces pretty much. I'm only thinking about the interfaces. What do I want it to do? What state do I need to keep track of? And then all the implementation details are just handled for me. And I like that because in the end, it's the interfaces that matter. So SudoLang is not object oriented; it's interface oriented. Right? And you don't write functions. You basically say, if you wanted to write a function, you just name the function and it writes it for you. It fills in the missing details for you. It infers, right? So keys to being successful with SudoLang: first, go to the SudoLang source code repo on GitHub. At the bottom of the README, there's like getting started guides with like links to a bunch of articles on how to write it and what SudoLang is and stuff like that. And that'll get you started with it, right? And then when you're using it, remember that the AI is an intelligent thing and it can infer a lot of things, and you need to lean into that inference. In fact, if you try to over specify, you'll make it perform worse because you fill up the context window. And when you fill up the context window, you don't have perfect attention. The AI can't pay perfect attention to everything in the context window. So even though GPT-4 has like 8,000 token context, you can really only use about 2,000 of those tokens and still get good attention across that context. So, and that's because it has a limited number of attention heads, and attention heads are really expensive to scale. So I don't know the particular details of how many attention heads is in GPT-4, but I can guess it's probably around 1,000, 1,024-ish, right? Or 1,040, somewhere in there. The Llama 2 is open source, and you can see how many attention heads it has. It has a 2,000 token context window and I think 32 attention heads. So do the math. It's got to spread that attention across all of those tokens, and it can't do it perfectly. So yeah, lean on inference. Don't type everything. Don't overspecify. And overspecifying would be defeating the point anyway. What you want to do is less work, not more work.
So when you're writing SudoLang, you should like really lean into constraints. Like you set up a function and you say like, these are the things that I want to be true about it. Everything else is up to you, GPT.
Yeah, basically, or even less, right? No constraints, just the function name. It can usually figure out the rest based on context. So only write constraints when it's doing something wrong and you need to correct it, pretty much. You need to guide its output to a more successful output. That's when you add constraints.
One of the interesting things when I was like going through the SudoLang documentation and everything, and you mentioned this a little bit earlier, but as like SudoLang could be useful for like certain chat applications or certain like structured chat applications. So you have this commands feature. Which is, if folks have used a Discord bot or something like that, this is like a / command, or in Slack or whatever. This is a very common interface. So it's just kind of interesting to see that bundled up together in this sort of like SudoLang specification. What are commands, and what was sort of the impetus in adding that into the specification?
So very often I'll be using, if I'm doing something like programs that write programs, then very often I will need multiple phases of prompts to get the context into the language model for everything that it needs to know to do a good job of its output. And for me, the most natural way to do that was / commands, and just telling it about those / commands. It first of all, it recognizes them instantly. It knows exactly what they are without any prompting. And if you just add a / command help, right, and you don't even tell it what help is supposed to do, it'll just list those commands for you. So I I had the idea. I tried it out. It worked first time. I was like, okay, this is going in this spec. This is awesome. And I use them all the time.
Yeah, it seems like the dream way to write a CLI. Like you just like specify kind of the shape of what it does, some commands it might have, and just a thing does it all for me. Sounds like a dream.
Yeah. So one interesting thing, when I was working on building the agent orchestrator from JavaScript, I was like, okay, I want to be able to edit my SudoLang prompts and just in SudoLang format and just a natural text file, right? But then I want to also be able to import those prompts as modules in JavaScript. So I had it write a CLI. I created a SudoLang interface that specified a CLI to do that conversion for me automatically, and it did that, and it works great. And then I went and put it in my package.json file. I have a watch script that just watches my prompts directories and automatically converts them into importable JavaScript modules. So now all my prompts are importable JavaScript, which is great.
That's really cool.